Let's start. Morning, Giselle. So this is what it looked like at about 7:15 this morning. Uh, Sun just coming up, sort of nice. Tomorrow's going to not be quite so nice. That's going to be a really stormy sea tomorrow. Um, but those of you that are not in Nova Scotia may not be aware that we have a hurricane on the way, supposed to make landfall a bit to the north of where I am, um, towards Cape Breton. And hopefully we don't get it too bad, but our area at least, we're getting high winds and an awful lot of rain. We'd like the rain, but the winds are going to be dangerous. It could well be that we don't have a class on Wednesday because I have no power or I've lost internet. So I'm going to try before then to pre-record a class, put up PowerPoints um, uh, that you didn't know, Jacob. Oh my God, this is all the news. Yeah, especially if you're in Cape Breton, you're going to get the worst of it. Anyway, the uh, big storm coming. It should be passing by Bermuda at the moment. That I understand Bermuda was able to survive Paulette. At least our one student that I know of that's there still had internet connection, but he was scared about what's going to be happening, I think, today. Um, anyway, let's get on with the show. Hopefully we can still run our test on Friday, that we don't have a big long outage, but we'll get things sorted one way or another for that type of thing. I'll try to have everything up and running, and if you've got internet, you'll be able to do it. And if you don't, well, we'll have to find a solution to that. Don't worry about it. Um, any problems of that nature are my problem, not your problem. I'll always find a solution. So let's get going. Um, so last day talked about trying to define a data problem. We need very specific questions so that we can then decide exactly what data it is we need. And generally, the data that's available isn't exactly what we want, or it's not in the form we'd want it. It's generally messy, dirty, it's incomplete. We have to do a fair bit of cleaning to it. And we're going to start into that data preparation today with Excel. So we're going to look at a data set in Excel. It's a messy data set, and it's got a lot of stuff that we don't really need. We're going to use one particular function in Excel. If you've done SISI 1225, my understanding is that you get exposed a lot to this. That's what the instructors tell me. Students last year, it seemed to be something brand new to them. Many of you in the class are transfers. Students from NSCC said that um, uh, um, about the Giselle, about the discussion. No, I haven't gotten a clear answer from them on that as to why some are viewers successful ones are not. Today, I'm not going to use the discussion tool. I'll ask you a few questions along the way. We've got a lot to cover, and I'll be using chat as much as possible to get feedback from you. I want quick feedback on stuff. It's a heavy class. The next few classes are pretty heavy. But I'll go back over it if students don't understand it. So just to give you an idea, this is trying to think of what does data look like. And you've been answering questions about COVID in the discussion forum. This is fatality data. Assignment 3 just came up, right? No, that was assignment. Chapter 3 is, I just posted that one, yes. That will start in on Wednesday. So uh, uh, each morning I make a copy of data that's on Google about COVID. And the um, this is the daily fatality counts. You see them up and down and up and down all over the place. Any thoughts on this data? It's looking stable. Yeah. Um, that it's stable and high. That those little peaks in the last few months have been 1,500 deaths. The valleys have been down around 100 or 200. Cases decreasing. The very first bit over on the far left was New York and New Jersey, and it was just going crazy. I don't know if you can pick it up, but it looks like there's a spike, drop, 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 then spike, drop, 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 spike, drop, 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 drop. And actually, that's pretty regular as to when it is. And it turns out it's a day of the week effect. It's when people do, or states do their reporting, or hospitals do. And the data, like for today, is very, very, very low. Generally, Mondays are a low day, and it's based upon stuff that was reported on Sunday. And I don't think they do reporting on Sunday. So we're going to get a big spike tomorrow because all the stuff that wasn't reported. So we've got issues about when they get around to actually reporting and how. This is Canadian data, and you'll notice we're down. It's very, very low. Generally less than 10 per day for the last, almost 2 months. Before the second wave, not necessarily convinced. The first chunk there it was nursing homes drove up most of that. It was people over 65, me. The ones now are all over the place, and mostly infections tend to be young people like yourselves. Or students at Western University at the moment. They've got quite a few cases. That really, really tall spike partway along, that was a data problem that I think it was in Quebec, where they had a whole bunch of cases that had not been reported to the Quebec government of people passing away. And they all got reported one day. And so they had a triple, quadruple day happen to them. And here's Sweden. I picked Sweden. Early on, people were talking a lot about Sweden. Sorry, Dora's barking. Oh, guess she doesn't want to come in. Sweden didn't implement a lot of controls. And they tried herd immunity. It turned out to not be necessarily a great idea because the Norway and Denmark, which are very similar countries, had very, very few fatalities relative to what Sweden went through. Yeah, what's the bar that goes down? Yeah, good question. It turned out that from one day to the next, so what I'm tracking is how many in total they've got. That's what Google tells me. And so I do a subtraction each time. And then there was one day where the total number of fatalities was smaller than the day before. And if we go and look at a number of countries on MSN site, that actually happens with several countries where it seems they make corrections to their data. And so the fatality count becomes negative. What I'm trying to point out is that here's data that is, Google's producing it or publicizing it. I would have thought it would be somewhat believable. That MSN is with ABC News Media. I would expect, this would work better. What slide are we on? I'm on slide 6. So we're often consumers, and more often we're consumers than producers of data or summaries from data like that. And so you've got to think of where the data comes from and be very critical consumers. So to be good consumers, you've got to see it then from how is the data produced? Where do they get it from? How do they massage the data? That sort of thing. So much of the course, we're looking at doing the data analysis. And it may be that when you finish this course and go on, you don't have to do analyses, but you're going to be reading other people's analyses for all kinds of things. And you've got to be smart consumers. So at the very least, I want you to be a smart consumer. So I'm on to slide 8 now. So if my business issue was trying to look at student expectations of earnings, what your salary would be 2 years after you graduate. I might be interested in knowing if students are fairly similar in their expectation, or is there a lot of variation? The variation, is it by program? Is it that business students expect to earn a lot more than art students? What about domestic versus international students? Depends upon where they think they're going to work, maybe. Uh, and males and females, are they different from one another in terms of expectations? We know in the workplace, females earn less than males in comparable jobs. Um, do they change as they progress through their program? What you think you're going to earn after graduation when you're in your first year, is that different from when you're in your final year? Uh, do they have concerns about even finding a job to earn money? And are those expectations different for ones that are very concerned versus those that are not concerned? There are all kinds of different things that you may want to start thinking about. And so this question is picked because we've got a data set to work with. And this is the data from the winter of 2010, when a survey was done across Canada. About 30, 40 universities participated. St. Mary's was one of them. I can't remember who ran the survey. I was involved in administering it, but I really can't remember anything about it from 10 years ago. But there were a variety of questions in it that had to do with these outcomes. So first, I'm looking at outcomes that I wanted to look at. And so about concern about it and what their expected salary would be and how long it might take them to find a job. And those are outcomes. So I'd also like to have a good sense of, uh, who they are. If I'm going to do comparisons of male or female or domestic or international, um, or what year they're studying in or where they're from, I need to have collected the demographic data. So these I'll use as inputs to give me insights about the outcomes. And that's very common that we're looking at a relationship. And definitely in models that we want to predict something, we're looking at what do the inputs tell us about what the outputs are. That with Target, it was what is all that customer data that we've got help us in predicting, are they pregnant or not pregnant? And so we've got a data file. I'm going to use Excel that it's actually not student survey data, it's student survey data 2010, I believe. So if you look at Top Hat, let me just get this guy out of the way for the moment. I can't get it without getting out of my presentation. But if you're in Top Hat, you should be seeing on your left-hand side. Let's see if I'm just afraid we'll lose something here. Now we'll find out. Over here, I've got a thing called data files. I don't know if you can see that. And there's student survey data 2010. Oh, there's my slide 11 still there. And so let me see if I click on this guy, what happens. I can download the file and then I can open it in Excel. I can do whatever. You can save it on your own computer or you can open it in Excel. I've already got it open. So I'm going to switch over here to Excel. And there it is. I'm going to make this a little bit smaller. Drag it over here if I can. And I'll drag it down this way. Now I can see the chat. So hopefully this still works. I can't see my slides anymore. So I'm going to have to flip back and forth to see what those are. That so what did I have for my slides? Let me, and I'm going to go back here and let me see if I can go back to presenting slides. This is crazy. And we'll move ahead in the slides. One more. Oh, there we go. Okay. So yeah, there's in my slides. You can see an example of what that screen is. I'll make the slides visible to you after class or after my second one. But when you're looking at it, look at that. This is what we commonly get in a data file. A data file, I've got each row is a single student that responded, and each column that I've got here is a question on the survey. So each one had an ID number. Oh, that's not the, yeah. And what survey language it was, because you could do it in different languages. And then there was question 1, question 2, question 3. What are these different questions? It's hard to figure out. That the raw data often is not all that clear to understand. Now, that's why generally any data file should have a data dictionary. I've received numerous files over the years where they didn't. And they may have sent me a separate document or something of that nature trying to tell me what the data is, but often it's very incomplete. This one, what you're seeing is the data file as it came to me from the group that conducted the survey. And they gave the data here, and then they gave me 2 other pieces of information. There was question numberings. This was helpful. It told me question 1 was, in what province is the post-secondary institution you're currently enrolled? What institution are you enrolled? And what year did you first enroll? So it tells me what the questions were that they were answering. But if I look at the data, here's question 5. Question 5, I think, told me what program you were in. So what's program 4? What's program 6? Program 7? Program 8? What do those numbers represent? So when they were telling me, that in what program are you currently enrolled, question 5, I don't know what the numbers mean. Normally in a data dictionary, it would have these are the labels on the different columns. It should be telling me what the question is, and then there should be an explanation here when I'm looking at question 5 of what is a 1, what's a 2, what's a 3, what's a 4, so on. They had another tab that was called interpreted data. And for question 5, it summarized it in what type of program are you currently enrolled, and it had education, visual. It didn't give me the numbers, but by digging around, I discovered this is a 1, that's a 2, humanities is a 3, 4 is social sciences, like sociology, anthropology, 6 is business, that's what many of you are in, 8 was math and computing science. So I've got an idea then of what these different things represent. Okay? But still, there's a lot here. If you go across, there's a huge number of different columns that are there. So I've gone through, I've looked at question numberings to tell me what they represent, as I showed there, and then the interpreted values help tell me what the numbers are. That you should have some sort of tab that is going to give us information about what the data is in here. You may also have a description of how the data was collected, where it came from, anything else that's associated with the data set. But as I said, many data sets, there are ones that are available for analysis and that sort of thing, people messing around with data analysis. There are a number of websites, but often there's very little information given about how the data was collected and what everything means. You have to guess, which isn't the way you'd want to function. If it came from an administrative database, that usually we've got a great big book that tells us what every field in our database is and what values you're allowed to have. For Manor, there's a whole bunch of different books to go through to describe everything because it's such a complex database. That you will notice with some of these that particularly if you look at interpreted values, these were the different sorts of programs, and many of them we don't offer. And if you go and look at the values in the database, you'll find that there were students that picked education or visual and performing arts or those sorts of things. Why did they pick programs we don't offer? We'll have to go and see what does that mean. So we'll get into that. That there's a lot of variables. For our questions, we don't need all of them. The headings are hard to understand. The values are hard to understand. That in the data preparation stage, usually we try to shrink it down to something that's more manageable that we can work with. And we may change some things around. If you are using a statistical software package, and there are many out there, that they generally separate out the data, and the original data is never changed. It's sort of protected. And any changes you make is captured in a script. It records everything that you do, and it may record it like a computer program so that you could go back and rerun the script to repeat all the changes you made. But at least there's a record of everything that you did. And if you mess up and damage something, you can go back and fix it again because the original is still there. Excel doesn't keep a record of anything. As soon as you change it, it's changed. You can't go back. Sometimes you can hit an undo, but most of the time, don't trust it. Once you changed it, they're permanent. So be very, very careful. You can either save a copy of the spreadsheet and put it somewhere. You can go and protect the page in your spreadsheet. I'll show you that in a second. But generally, copy out what you want and work with that. So with this spreadsheet, where am I back again? What I could do is here's my first data stuff. I can, if I want to, go back here, and there is if you hit File in Excel, that's up here in the top left corner, it allows you to protect your workbook, and that I can just protect the current sheet or the whole workbook. That's up to you. You can do all kinds of restrictions, that type of thing. So it's a good idea to protect it and how you want to protect it. You can put a password in there. If you put a password in, make sure you remember it. But with this, whoops, where am I now? There we go. It's back to my slides. I'm going to just copy the variables I want. So copy the questions that are of interest to you and copy and paste them somewhere. So I've already been doing a lot of this stuff, but what I could do is I'll just show you. So I click on a column that if you right click, you can do a copy, and just hide that. And the plus sign down here allows you to add a new sheet, and I'll just drop it in. Boom. Okay, there's ID. Generally, we always keep the ID. With this one, I want question 3, I want question 5, 7, I want, I think it was 10, 11, or whole bunch. I think these ones are all ones. Now, I've grabbed more than I wanted, so I just highlighted a whole bunch. I can go back to this, hold on. Where's my new sheet I created? There it is. And I could drop it all in here. And I could just delete the ones I don't want. I don't want question 4. What else did I want? I wanted 3, 5, 7, 14, 15, 16. Okay. So let me go back here. I'll get rid of this one. I didn't want these. I'm clumsy here. And I forgot question 16 I wanted, I guess. I think that was how long it was going to take me to find a job. So, put it in my sheet. Okay, so I can go and copy all the ones I want that I should rename this thing. What's sheet forward for? So I could rename it something. So maybe I call it grad expectations or something like that. One over here called that, but I'll get to that guy. So just copy and paste them whichever way is most convenient for you. And so this is, there were a bunch of others I wanted to. But anyway, I also wanted 53, 54, not sure about 55, but 56 and 57. So I'd say having the ID is really important. It's not data I'll analyze, but it helps me keep the rows organized and give it a name. And that Danielle, I'm not sure if you're on this call, so use chat. If I go back here, this stuff here, I would strongly recommend that you just click on any cell that's in here. Go up to Insert. Go here to Table. Click Table. It'll pick the columns and rows. Now I don't have all my table in here, but hit that and you get a nicer looking table. It's got these alternating bands across it. Makes it easier for me to read across. So number 10 is record 472, came in 2009, is in program 6, lives in 7, gave these answers here, expects to earn $10,000. I can't remember what 6 represents there, but I could read everything to do with that particular student's response, and it makes it easier. Along the top, it gives me the labels. It's got these arrows. I'm not going to use them today. I'll use them next class. But it's a really nice way of exploring your data set, allowing you to do some quick and simple sorts of things. Now, this is proper data set. Okay, I've relabeled it grad expectations. It's sitting on Top Hat right now. So you'll see after we've done everything today, what that data file is going to look like. So we're going to be making changes as we go. So as I said, Excel normally knows where the data file is. This one, it's going from A1, that's in the top left corner, and it goes all the way across to column N, which is way across on the right-hand side, and to row 812. That Excel, when it pulls it up for the table, puts dollar signs around it. Don't worry about that sort of thing. If you're familiar with Excel, you'll know that it loves putting in dollar signs, and we'll be using that later. So as I said, it makes it easier. Those down arrows are a very powerful tool for sorting through my data. That by just having the variables I want, you could view that as feature selection. You are just looking at what you think are important variables. But they're still hard to read, and the numbers are not the greatest. So I could start out by changing the labels that I've got in my spreadsheet. So, I already did that. I went from having columns that had cues and that type of thing. I looked at what the questions were, and then I retyped the labels in it. Where is this sheet here? Here's the way it looked before with these things. And I went and took this one here, and this was the year they started. Let me make this bigger so you can see. And this was the program they were in. And just go and type on top of it. This is where they live. Where's your home? This is, are you worried about finding any job at all? I could keep going across and I'll rename them. And there they are. That's my new names going across there. And the other variables that I forgot to get were things like gender, age, parents' education, and what language they speak at home. That if I go back here to my slide, that so I could rename our variables, make the presentation easier. So I've done that. And here's the proper labels that I was going to put in. I gave short names, but it's easier to remember these short names than those cues. But the values are hard to understand. So now I'd like to transform those, change them around. Last class I talked about transforming our values. So I'm not going to worry about clicking on the down arrow because there are lots of things we can do. We'll do that next class. I'm going to take start, and if we look at start, here it is. And if you did click on the down arrow, it shows all the values that are there and different things you can do. So the numbers in that column could be 2002 up to 2009, and maybe some were blank. And that so the survey was done in the winter of 2010. So if you started in 2009, you're in your first year. You started in 2006, you're probably in your fourth year. That let me go and change things so that I can just look at first year, second year, third year, fourth year students. Just to try to make something. Now, many of you are in various years of study. Some of you just started this year, but in fact, you're into your third year of study because you transferred in 2 years of credits. Some of you started 3 years ago, but have only been part-time and still may be doing your first year. So the starting year may not be the right thing to use to be year of study, but it's an approximate thing, and I'm trying to keep things simple. But having all those different years was a little bit much. I'd like to know the difference between new students and students that have been here a while and do it efficiently. So Excel has a function called Vlookup, and it uses what we call a lookup table, and it goes and matches things. So it would take, if you started in 2002, we're going to call that year 4. anything up to 2006, we're going to call year 4. That 2007, we're going to call third year, 2008, second year, 2009, first year. Jacob said he transferred into his third year. He probably came from NSCC. But you're taking a mix of first year classes and third year classes, probably. That we don't go through in a lockstep fashion. But anyway, that what I'm going to do is create a new column in my table called year that's going to take the start values and convert them into the year values. So I'm going to go back here. So I'll show you what I'm doing. So I'm going to create a new column called year. So I'm going to select this whole column. If you right click, you can do different things. I want to insert. Boom, it put me a column over here. And I'm going to call this year. I'm going to put a formula in here to convert things. Now, it uses this lookup table. So I could put the lookup table somewhere on this page, but I normally like to keep all of that stuff separate. I've got a whole bunch of lookup tables I'll be using today, but I created this little table here. Hopefully you can see it, that it's got the start column, different values, and this is what the new values are going to be for year. 4, 4, 4, 4, 4, 3. These are tables that I used for other things, but whoop, someone wants out. So these are just simple text tables. There's nothing fancy in it. I've just typed things into these spaces. Okay. So let me go back here, and I'm gonna. Where did I do that? Grad X. Okay, sorry, I picked the wrong guy because this is the one that already has. Oh, there's year. Okay. That. So in here, I'm gonna type in equals. I'm gonna start typing Vlookup, and Excel guesses what I'm typing. So, okay. Now, it works first by picking what is the thing you want to change. The thing I want to change, this is for student number 432. So that value is in that second row here. It's in C2. So I'm looking at column C and row 2. I have to tell it where the table is. So I'm going to go over here to my lookup table. So I just jump right over to this other tab. And I'm going to take this table here. I don't keep the headings at the top. That I just need this table here. I don't know if you can see at the top of my screen, it's got my formula here that I'm working on. It's got A2 and a B9, and I can't make this bigger for you to see, but hopefully you can. We need to put dollar signs around this. So I can go and manually type it in, $1 in front of the A, $1 in front of the 2, a dollar sign in front of the B, dollar sign in front of the N. So this is my table from A2 down to B9, and my table will always be in this location. Dollar signs are a way in Excel of fixing things, because Excel sometimes thinks that your table might move and it might jump around. Put that in there so Excel doesn't think your table is going to move on you. That there are shortcuts for doing this. If you're familiar with Excel, I'm not going to get into that. I'll try to keep it simple. I'll manually go and type them in. Now it asks for, where is the new value? This is the old one. That was what's in C2. And my new one is in this table in the second column. So I type in a 2. And then it asks for two things. It asks, should I put a true or a false? This particular case is called an exact match, and you put in false. I find it very confusing. Why not just type in exact? I don't know. But so this is my formula. And then when I hit enter, what happened to my original sheet? It'll throw me back, and it filled in the whole column. So for 2009, it said year 1, 2006, year 4, 2005, year 4. It did it all correctly. In a table, it's assumed that if you're putting a formula in there, the formula applies to everybody. Everyone's going to get treated the same way, and it fills in the blank for you. If I hadn't made this a table, I would have had to copy that formula into each one of those boxes there. So it did it for everybody. With a data table, it thinks everything in the column is the same in one sense or another. So this becomes a quick and simpler way. Where am I here? Too many tabs. So I did that, as you can see, and then I put in my formula. As I said, I started out with a C2, and then I went to my lookup table, and I put in my dollar signs around things. Then I told it was column 2, and I told it was false. And I put all that stuff in, and I got the results I just showed you. So it's a very quick and simple way of doing that. And we can go and do that with other variables. We've got at St. Mary's, arts is humanities or social sciences. Business is business. Science, that we have physical life sciences as well as mathematics. Engineering, we only offer the first 2 years of a Bachelor of Engineering, but you could put that into science, or we could keep it separate as a label. And then there were a lot of other programs that we don't offer. And we can do 2 things with this. We can either say, yeah, those students were just messing up our data, and they're not valid students, or they're not valid responses because we don't offer medicine. Let's throw that student out. Or we could think, maybe they misunderstood the question. Maybe when they picked law, they really meant criminology because they didn't know that criminology was a social science. Maybe when they picked medicine, it was because they've thought of themselves as in a pre-med program, and they were then going to do 2 years of science and transfer to Dalhousie. And so they clicked medicine. And some of the other sorts of things, maybe they just were unaware of what they represented and were confused that way. And we might be able to guess what would be good answers. So that's what I did. I didn't want to lose any data because there's a lot of data there that I could be throwing away. I thought the education was probably art students. Visual and performing arts, they just saw the word arts and picked it. That medicine, I thought, was probably science. That agriculture and environmental science, we do offer an environmental science major, and it would be in science. Subsequent to this survey, we did introduce an environmental studies program in arts, but it didn't exist then. I don't know what to do with health, parks, recreation, and leisure. I picked science just because of the health word. And personal protective and transportation, I thought that might be criminology on the protective services. And law, I thought might be criminology. Other is other. So I created a lookup table that looked like that took each of those values, 1 through 14, and assigned them in that fashion. Now, here's my lookup table in Excel, and you'll notice I've got 3 columns. I took this original description and my new description. So I had 3 columns in this lookup table. And this is going to make things different when I use Vlookup with anyway, we've seen at the moment that we've got some problems in our data, and that there may be data entry errors, maybe they misunderstood the question, maybe they're just messing with our heads. But with this one, what I did is, let's go and demonstrate it. So I took the program column and I'm going to insert a new one. So I select the whole column and I do an insert. It then gives me a new name, column 1. Well, I want it to be called program. I've already got a column called program. And move this over so you can see. It changed the name. In a table, every column has to have a name. I can't have a blank column. Excel automatically gave it a name, column 1. It didn't just give me a blank column. Normally, when you insert a column, it just gives a blank name. It's all blank. Excel won't let me do that, not in a data table. And each name has to be unique. They have to all be different. These are different variables, in a sense, that we're studying. And so I don't want to have two things that are both the same. I put in my formula, I did last time. My old value is in column E, row 2. So I put in E2. My lookup table is over here. Now, I don't care about the stuff in the middle, but I'm going to grab the whole table anyway. I'm going to put in dollar signs. You may not be able to see these. And then I have to say, where is the new value? And the new value is in the third column of my new table, of this table. And again, I want to do an exact match. Enter. It fills it in, and there we go. So program 4 is arts. This is business. 7 is science. 4 is arts. 8 is science, and so on. 13, I made arts. 14 is other. Don't know what other is. And I can go and do this type of thing with all my different variables. So what's my slide say? I'm not sure what my next slide is. So I could go and do this with all of them. And I've got a new tab in my table in my spreadsheet that where I got all of it done. Okay, this is what I end with now. So I've recoded everything. So you see program is recoded. I created a new one called home. Notice it changed this to home too. So where are you from? That, don't worry about this guy, I'll come to that. Gender, I'd like you to look at these last columns. So I've got gender. Gender 2 is the original value. It was zeros, ones, so on. Parental education, it was a bunch of numbers too. And language was a bunch of numbers as well. And when I put in my formula, look what happened. If the person was a 1, I'll just show you the lookup table here for this, for gender. Here's my lookup table. If you're 0, you're a male. If you're 1, you're female. Parents' education, if you're 1, you had high school education. 2, college education, so on. Language, if you're a 1, you spoke English. 2, you spoke French. 3, you spoke something else. So we've got, it matched up, the 1 being female, 0 being male correctly. It matched up 1 being high school, 5 being a master's degree, these ones being English is their language. But look at these things here. If gender was blank, they made them male. If the parent's education was blank, it came up not applicable. NA, that's not applicable, shorthand. And same with language. So it treated blanks in different ways. That they, what's happening here with Why is it treating gender differently from parents' education? Shouldn't it say not applicable, that we don't know what the gender is? Any thoughts as to why gender is showing up as male and not just we don't know? Anybody want to try answering through chat? Is anybody still here? I can never tell. Okay, someone's typing. That is it the default? Well, the default. But why is the default for gender different from the default for parent education or language? Um, we're not on a slide at the moment, Esther. I'm flipped into my Excel file. Yeah, Excel thinks a blank is a 0, so shows it up as male. So, well, if it's a 0, why didn't it do something with parent education? If you look in the table, for parents' education, we don't have a value for 0. If we did, it would put something in. So like if I put in, let's see if I put this in and see if it works. That the let's say that a 0 is a genius. Back and see if it. Nope. I've got to refresh things, I think, to be able. Oh, I do. Just change this. I'm messing around with this, but I added a row, so I need to put an extra row in there. There it goes. Put in genius. When there isn't a value in your table for what you want it to be equal to, then it comes up and says not applicable. If the value is in your table, and as again, it's going to take a blank as being a 0, it goes and assigns that value. And so for gender, it took the 0 here and made them male. You've got to be really careful about recoding your data. It can do things that you didn't expect it to do. And there's ways of trying to deal with this, but be careful. Okay? So that, as I said, it's back to my slides. This is how it ended up treating things. We could go and try fixing it by using an if statement. So another tool within Excel, there's Vlookup, where it uses one table to match another thing. If does things one at a time. So I could say, if the value in my spreadsheet was blank, a blank is 2 double quotes, then keep it the same. So Excel takes a statement. The first piece is a statement that is true or false. If it's true, it gives you the first entry here. And if it's false, it gives you the second. And so I inserted this around my formula. It says if O2 is blank, leave it blank. Otherwise, use VLOOKUP. So I could go back and do that. And here's my data here. So here, it's got this big long formula for VLOOKUP. I could insert at the beginning. I don't know if you can see this. If like that, and gender 2 happened to be, sorry, in this table it's P2. If equal, P2 is equal to a blank, then keep it a blank. And if it's, I've got to put commas around these things. And I've got to add an extra bracket now because I've got a bracket back here and a bracket over here for VLOOKUP. So, and it fixed everybody down below, made them all blanks. That actually can cause other problems, putting these if statements in, but it at least cleans it up in terms of they're not labeled then as male any longer. They're labeled as blanks. but actually Excel will treat those blanks differently from those blanks. And I'm not going to get into that right now, but it can do strange things. We have to be very careful when we're recoding our data. That if you're doing serious data analysis, you'd probably use other software than Excel. But Excel does almost everything, the quick, simple stuff that we want to do when exploring data. Now, I said that's an exact match. What's an approximate match? Well, look at the salary data. Salaries are all over the place. They're from, let me go back and look. Here's salaries. There I've got some that are blank. This person gave a salary of 450,000. This one 20,000, 60,000, 10,000, 43,000, 39. I don't know. These are odd numbers. I would have rounded off to like 60 or maybe 40 or something like that. But some of these are strange sorts of numbers that they picked. But suppose I want to recode them. And here's what I've done. I've already done the recoding, but let me show you what we're going to do. So I've got a table, like a lookup table. If you're between 0 and 20,000, then I'm going to say your expectations are very low. 20 to 40, I'll say low. Average is 40 to 60. The high value might be 60 to 80. 80 to 100 is very high. It's how much you're going to earn 2 years after you graduate. And above 100,000, I think that's rather unrealistic, but I guess it's possible. And so I'd like to just put everybody into a group so that I can quickly scan. And when I see their salary figure, I don't have to think, is that a big number or a small number? I've given it a label instead. And sometimes we just want things into categories. How do I do that? I could build another lookup table. Well, this one, though, is going to look different. This is the lookup table I'm going to use. That you'll notice it only has one number. The first group is 0 to 20,000. I just put 0. The second group is 20 to 40, but I just put 20. I just put the starting value for each group. And that I know that the first group ends where the second group begins. They have to be in ascending order like this. But the end of one group is the start of the next group. And so I only need this as being my lookup table. And I'm going to put it through the same way I've done before, but now I'm going to use, instead of false, I'm going to use true. And if I used, well, I'm going to do it twice. I'm going to show you. If I had put it in here, see, I've got true in here. I don't know if you can see that, but if I had put in false instead, what's going to happen? You'll see for 20,000, it'll say low. For 60,000, high. This is the start of the low group. This is the start of the high group. This is the start of the average group. Blank, or 0, is the start of the very low group. All the other numbers aren't in this lookup table. My lookup table for it was over here. It only looked for those that were exactly the same. All the other numbers, it didn't accept. But if I go and make this true, it goes and puts it into them as if they're a group. So it looks at the highest group I can put it in. 20,000 I know is the end of the first group, but it's the beginning of the second group. So it'll push it into that second group. That 90,000 is right in the middle of the group that goes from 80 to 100. And so it would put it in that very high group. 85,000, the same way, fits easily in the middle of that. The average group is from 40 to 60. So down here, 44,000 got into the average group, whereas 39,000 was down into the low group of 20 to 40. So an approximate match is a way of taking numerical data, and it can only work with numerical data, and converting those numbers into groups. So it condenses your data in that fashion. And very frequently, we will want to take values and put them into categories. It simplifies the data in some fashion. So these are some of the most standard things that we do in transforming our data. Sometimes I have formulas that would work out a total of things. So if I had had students' expenses for books, for tuition, for living expenses, and so on, and I want to know what their total expenses are, I could have done that by having a formula that would be in my total expense column. If various things I may be able to work out as averages or totals, percentage change or something of that nature that takes place during our transformation. But we've got to be careful that as we recode the data, we may end up getting unexpected results like we had for the male-female situation or the not applicable, that we've got to be careful of how we're doing these different types of transformations. So I was up through this sort of quickly. But now that I've got it formatted this way, let me go back and look at, for example, row number 10. And do I actually have it here? No, I don't. Go back and look at student number 10. That's this one here. So this is a student that is in first year, just started in 2009, studying business, is from Nova Scotia, and has very, very low salary expectations when the student graduates, only 10,000, is a female student, and isn't sure about parents' education, and first language is English. So by changing things from numbers like this, what's a 7 mean here? What's a 1 mean there? What's a 1 here? What are some of these things? Is 10,000 a big number or a small number? I've been able to recode this in a fashion that is much easier to read. I've kept all the original values here. Sometimes I then go and strip out some of these sorts of things or just copy the new values and work with them. But it's useful to keep both side by side so you can double check yourself to make sure you haven't made mistakes. And I make lots of mistakes, and you probably will as well. It's natural to do that type of thing, unfortunately. So where's my slide next? So we've gone through a lot in terms of starting things up in with Excel, and things actually will accelerate a little bit in the next few classes. So I've created a new file to protect the original, or at least I created new sheets and kept the original sheets that had my data. Table function is one that's really useful for data analysis because every row represents a different record, makes it much easier to read and to manipulate the data. We've renamed the variables, that we've recoded the values of the variables using Vlookup or using if statements. There are various other ways you can recode, as I said, with formulas, that type of thing. But recoding, transforming your data is trying to just put it into something simpler. Oh, I haven't done filters and sorts. That's for next class. Should have cut that out of there. And we started aggregating our data with an approximate match. And we're going to be getting into a lot of data aggregation. Data aggregation is taking a large data set, a large number of numbers, and trying to squeeze it down into something smaller, simpler to explore. To look at 811 values is too many. That from a data science perspective, few things pointed out the need for a data dictionary to give you all the information you can about what those different values mean, where you got the data, how it was collected, those types of things. Make sure you protect your data. I've destroyed too many data sets over the years because I started doing analysis and changing my data without saving the original. And then I'd have to go and, if it was data out of Banner, I'd just do an extract all over again. But if it was a survey, um, I may not be able to reconstruct the original. We started doing preparation, data preparation today. And that's really important to make the data set easier to work with. But be careful, you sometimes have unintended consequences. And we've also noted some strange things. We had missing values and what happened there. That $450,000 salary figure, probably a data entry error, probably should be 45,000. And we had misunderstandings with respect to some of the questions. What program are you in? And giving me values that were incorrect. So last class we talked about data quality. Those are big issues and ones that often you start discovering as you start looking at the raw data. So, whoops, what's next? That we're going to be looking at characteristics of a single variable. So we've got a lot of variables here. Let's look at them one by one. If I was looking at salary, what would be a typical salary? Where's the middle of my data set? What would be a middle value? What would be a low salary? What would be a high salary? What would be unusually low or high? Now, I made up categories to summarize my data. Were those appropriate values to pick? What would we consider an outlier? An outlier is an unusual value. Under what conditions do we call something an outlier? Can we summarize the overall pattern that's there? And can we do it numerically or graphically? What are some of the common patterns? We're going to start out summarizing things with simple graphs or tables, then move to numeric summaries, and then start to look at summaries or patterns when I'm looking at relationships at maybe two variables at once. And we won't get that's further away. That'll be in chapter 4, as we start getting into patterns and relationships, and chapter 5 as well gets into those sorts of things. And how do we look at categorical data versus numerical types of data, salary versus program? And what do we do if we have several categorical variables? Are there different tools for analyzing it? And we'll be looking at that exploration phase a fair bit over the next 2 to 3 weeks before we actually get into actually building any models and doing value estimation and that type of thing. That brings us to the end today. That for this table function and Vlookup, there are videos embedded within chapter 2, and you can try watching them as well. And I've recorded today's class, and I'll get that posted hopefully by end of day today, in case my power gets knocked out tomorrow and I can't post it tomorrow. Okay, take care, enjoy the storm, and maybe I will see you on Wednesday. And if you aren't hearing from me, that may be because I have no power to be able to contact you. Don't worry. Bye-bye.